Here we're going to look at a '07 Buick Lucerne. This system is called a waste spark system. Essentially, it uses one coil pack for two companion cylinders. Companion cylinders are a pair of cylinders that are on top dead center at the same time. When it triggers this spark event, the cylinder that's at the top dead center of the compression stroke, called the vent cylinder, will then enter the power stroke. The cylinder that is top dead center of the exhaust stroke is then the waste cylinder, creating the waste spark. Here we can look at the wiring diagram. We can see how all three coils, because this is a V6, is supplied by one ignition voltage, and then each coil has its own ground wire and ground circuit that the PCM can control. Here is where it removes the ground to trigger the ignition module. We can also see in the red here that these are divorced coils, meaning that there is no connection between the primary side and the secondary coil. There in the red we can also see how the secondary coil feeds cylinder 2 and 5 on that particular coil pack. Here we can see we are measuring the resistance of the spark plug wire for cylinder number 1. This is about 1.5 kilo ohms. We can see in the specs here, the spark on the bottom, the spark plug wire resistance spec is about 3,000 ohms per foot. It's about half of a foot, so that is right in spec. We can also see the firing order given to us, the spark plug gap that is recommended, along with the torque and the recommended spark plug type. The ignition system on the Buick is controlled by the ignition control module. The ignition control module supplies the power and low reference circuit to the crank position and the cam position sensors. There is a low reference 3-time signal and a high reference 18-time signal. Using this data, the ignition module can time the spark to the correct time. Here we can also see certain resistance values for the cam and crankshaft position sensors. Because this coil pack is considered divorced coils, we can measure the resistance of the secondary side. Here we are going from one terminal to the other terminal on the waste spark system. We measure about 5,000 ohms. Here we have a spark tester on cylinder number 1 plug wire and waste spark system. We're going to crank it and we can watch as it'll show it's sparking. Go ahead and crank it. Here we are looking at the Tacoma ignition system. We can see this is a coil on plugs system, meaning that there is one coil for each spark plug. We can also see in the yellow there that each coil pack has its own ignition trigger module in it. We can also see that the ECM is using the camshaft position sensor and crankshaft position sensor to time this spark event. Here we can look at the ignition system a little deeper on the Tacoma. In the red, we can see the primary side of the coil, as they all share a battery positive from the ignition switch, which feeds the primary coil and the module. We can also see in yellow the secondary side, the coil going to the plug, controlled by the ignition module in the coil 2. We can also see each module shares a ground in green. There's also a diagnostic circuit, IGF, that goes to each ignition coil. We can also see each ignition coil receives a trigger circuit from the ECM that feeds into the module in the ignition coil, then beginning and triggering the spark event. Here we can see the Toyota ignition system a little more in depth. We can see in each ignition coil, we can see both coils are a married coil. We can also see the igniter as a transistor in part of the ignition coil. We can see how it's connected to ground and to the primary side of the coil, and then leading into through a diode to the secondary side of the coil. The diode is there to protect the high voltage spike from going back into the circuit. We can also see the timing trigger, IGT1, triggering the igniter, and we can also see IGF is our diagnostic confirmation. What this does is send a signal back to the PCM, verifying the spark occurred. Here we can see how this interaction works between the igniter and the ECM. We can also see a normal IGT igniter timing and confirmation signal and what a malfunction would look like, indicating circuit open. And we can see some DTCs that would result from this circuit open. Alright, here on the 09 Tacoma, we are looking at some of the scan tool data. We can see our engine speed. We can also see our ignition advance. See at idle here we're about 9 to 8.5 degrees. We give it some throttle. It goes all the way up 30. We can also see trigger counters, a knock correction, and our throttle position.